All right, what is up, my pre-cal peeps? We are going to now use what we just talked about in setting up our SOHCAHTOA ratios, our sine, cosine, and tangent ratios. We are going to use those to find missing sides of triangles. All right. Now, you see that this has an angle measure now. Their theta is no longer there. Now we have an angle measure. Today we're going to talk about finding missing sides, and then tomorrow we'll talk about how do we find a missing angle if there's an angle we want to know. Okay, right now we know the angle. It is 30 degrees. Okay, now that brings me to a point. You are going to need a calculator. Either calculator from your laptop or device. If you have just this scientific calculator right here, a couple things about it. You will be using these trig functions in this tab here. Here's our sine, cosine, and tangent that we'll need. But no matter what calculator you're using, you're gonna need to make sure it's in degree mode. Okay, this one's already set to degree mode. I don't have to worry about that. If you're using a TI calculator, you're gonna have to change the mode. You press mode, go over to where it's the third line down says radian. You need to put that in degree mode. Okay, whatever calculator you're using, you're going to need to be in degree mode. All right. There is a link to Desmos on the home screen of the Canvas page. There is a link to Desmos here or here, whichever one you choose. You're going to come to this little wrench and make sure that it's in degrees. Okay. So that's just a little kind of some preliminary things that we got to be able to handle. Okay. Hashtag degree mode. All right. And as always, I hope you have some paper out that you're taking notes with. Right. You want to be able to refer back to your notes and not have to always come back and click on a video. All right. Make sure you're taking notes. You need to be in degree mode for our trig ratios that deal with degrees. Okay. First up, we notice it's a right triangle. We need to put down our trig magic word. Do you remember the trig magic word? SOHCAHTOA. Okay. We're going to use that magic word here in just a second. All right. So put that down on top of your paper first thing, and now we come label a triangle. All right. This has replaced that theta. This is now our reference angle. Okay. So first, across from the right angle. Do you remember what you call that? That's the hypotenuse. We're going to label it. Even if you abbreviate, do something to label that. Okay? Across from the 30 degree mark. That was theta in the previous examples, in our previous set of notes. Across from it, now we have an angle here instead of a theta. We're going to say that's still our reference angle. We want to label across from it as the opposite. Remember, opposite is across. Adjacent means next to. Now, there's nothing over here right now, so I'm going to go ahead and avoid labeling this. All right, so let's look at our triangle. What have we labeled? We have labeled the hypotenuse and the opposite. Okay, I want to come over here to my trig magic word and think about which trig ratio, sine, cosine, and tangent, has as its fraction the two parts that we have labeled. We have the hypotenuse and we have the opposite. Hypotenuse and opposite are in the sine function. Okay, so we are going to set up our sine ratio. We're going to say sine of 30 degrees equals opposite, which is x, over the hypotenuse, which is 12. And again, how did I know I was using sine? I knew I was going to use sine because of the things that I had labeled. I have an angle that I know, I have one side that I know, and I have another side that I don't know. I want to use those three pieces of information to dictate which trig ratio I'm going to set up. Since I knew the hypotenuse and I wanted the opposite for this 30 degree angle, I set up a sine function. Okay, now from here on out, we're going to do some solving and using our calculator. Okay, here's what I want. I want to undo what's happening here. All right, right now x is being divided by 12. How do I undo dividing by 12? Well, to undo dividing by 12, I have to multiply by 12. And if I do a times 12, this will get canceled out. But whatever I do to the right side of the equal sign, I have to do to the left side. Okay, so in my calculator that's in degree mode, I'm going to go type in 12 sine of 30. Okay, so I'm going to show you using the TI because that's what we'll use when we're in class. We're going to type in 12 and then sine. The trig functions on the calculator are right up here above the 7, 8, and 9, the next row up. So I've got 12 times sine of 30 degrees. Okay? And 12 times sine of 30 degrees is 6. So I know that the x is all that's left on the right side, and that is equal to 6. Okay? That's what we needed to go calculate in our calculator. Okay? Let me show you how to do it on the laptop calculator because things are a little bit different. In this laptop calculator and a lot of the older calculators, you actually have to type in your fraction first. Let me clear that out. Let me do this correctly here. 12 divided by, sorry, we're going to do 12, actually we're going to do 30 first, and then we're going to do sine, and then we're going to do times 12. We have to kind of do it backwards on some of these older ones. Okay, and 12 sine of 30, that's what that's showing me. Sine of 30 times 12 is 6. Okay, so whichever calculator you're using, that's my answer to this. So this x value, this side of this triangle would be 6. Okay, let's do another example. All right, here's another triangle. Okay, notice that the angle is not in the same spot as it was, but that's still our reference angle. Okay, again, first thing I want to do is write down my trig magic word. SOHCAHTOA. Okay, now I'm going to label my triangle. Again, right angle, find that first. This is what tells us we can use our trig magic word. We are going to label across from the right angle as our hypotenuse. Okay, right now there's nothing there, so it's probably not important for us to label it, but we probably want to make sure we distinguish that from our adjacent side. Okay, so there's a hypotenuse. Here's the angle across from it. Remember, we call that the opposite side. And next to it, we call it the adjacent side. Okay? Here are the three pieces of information. Okay? Now I'm going to look at my trig magic word, and I'm going to see which trig value has these three pieces of information in it. The angle, opposite, and adjacent. Okay, look in your trig magic word. Which one uses opposite and adjacent? Yeah, tangent. Okay, not tan. We're going to say tangent, not tan, right? So tangent of 50 degrees equals O, which is opposite, that's our x. A, which is the adjacent, so that's 5. Okay? All right, now it comes again down to the point where we're going to solve. Solve means undo, so I want to get the x by itself. I have to undo dividing by 5, so I'm going to multiply by 5. Right? Multiplying and dividing undo each other. So on the right side, all I'm going to have left is x. But remember, whatever I do to the right side, since I multiplied it by 5, I have to do to the left side. Okay? So I have to do 5 times tangent of 50. Again, I'm going to recommend, let's use Desmos this time. Let's try to use Desmos because I want to show you something. Again, on Desmos, you have to press this little wrench up here and make sure it's in degree mode. Okay? Then bring up your keypad, and your trig functions are right here. Click that functions button, and there's all your trig functions. Okay? All right, and we want it to do 5 times tangent of 50 degrees. Okay? Now we get this number here, 5.9589. Or if we wanted to round it to 2 decimal places, we would say it's 5.96. Okay, so let's go ahead and put that in there. 5.96. And this is approximate, so we really shouldn't have an equal sign, we should have approximate, but that's not going to be too big of a deal. Okay, if you were typing this in Canvas, it'd be 5.96. Or if I had you round it to the nearest tenth, well, that 6 would actually make that 9 round up to a 10, which means this is actually just 6. Okay, it's approximately 6. Okay, I'll accept either one. Okay, but the important thing is, do you know which trig ratio to set up? That's why the labels are so important. Okay, now both the examples we've done up to this point, this x has ended up being in the numerator. Okay, let's see what happens when that x ends up being in the denominator. So just spoiler alert. Okay, last example. Let's talk about it. Again, right triangle. So when we know trig magic word, put that down as you're working out your problems. Put that on your work. SOHCAHTOA. And again, this helps us remember the order and what things are related to each other. Okay, now come over here to your triangle. Here's the right angle. So what do we call this side? Hypotenuse. Okay, here is the angle that we're interested in. This would be a theta. That was theta yesterday on yesterday's assignment. Now it's an actual angle. Okay, opposite would have been over here. But since there's nothing there, I'm going to skip the label. But I know that that's the opposite side. And what will we call the 12 then? Since it's next to it, we would call it the adjacent. Okay? All right, so let's look at our labels. We have labeled the hypotenuse. We have labeled the adjacent. They want the hypotenuse, and they gave us the adjacent, and they gave us this angle. This was the angle that was important to them, and so that's what we're going to base our decision off of. Okay? Which part of our trig magic word uses these two labels? Cosine. Cosine uses A for adjacent and H for hypotenuse. So be careful how you set this up. It says cosine of 25 degrees equals, order matters. So in this order, A came first. So we have to put the adjacent on top. So the 12 will be on top. And the H, the hypotenuse, has to go on the bottom. Okay, notice how that's different. Look how that's different. Look what we did last time. Actually, the last two examples, x was on top. First example, x was on top. Okay, so now that the x is on the bottom, we can't do the same thing. Okay, our first job should be get the x out of the denominator. Multiply both sides by x. Okay. Now, x we don't know, so we actually cannot do that multiplication just now. We're just going to leave it as x cosine 25 degrees equals 12. Okay? So, how do we get x by itself now? Remember, this was multiplication. What do we do to undo multiplication? Well, to undo multiplication, we divide. But what are we going to divide by? Since we want the x by itself, we are going to have to divide by cosine of 25 degrees. So now instead of doing a multiplication, like we did the last two times, now we're doing a division. Okay? We're going to calculate 12 divided by cosine of 25 degrees. Again, I want to highlight this important before we go through and finish off this problem. When x was on the bottom, we ended up having to do a division. Okay? When x was on the top, we just did a multiplication calculation, because that's all it took to undo the division. Okay, but now that x is on the bottom, things get swapped around. Okay, so now let's go do that. Again, let's go ahead and do Desmos. Let's go ahead and pull up Desmos again. Where's that? There it is. Okay, I'm going to X that, clear that off so I'm not confused. All right, so what do we want to do? We wanted to do 12 divided by, and I love how Desmos we'll go ahead and put that as in the denominator. But I'm going to do, now we said it was going to be cosine of 25 degrees. Let me double check my calculations before I hit and say I'm done. Let me check. Yep, 12 divided by cosine of 25 degrees. Okay, 13.24. All right, 13.24. All right, just verify that real quick. Yep, 13.24. Okay, now on your assignment, I believe I've said just go to the nearest tenth. Okay, so you have to follow your rounding rules, right? Since this is 4, then there's the nearest tenth, nearest one decimal place. That means this x equals 13.2. 13.2 is what I would type in that answer blank in the assignment on Canvas. Okay, if this was 13.25, then I would make sure that I called this 13.3. Okay, but I've given you a little bit of leeway, and it'll accept some rounding errors. There should be some issues, but if you're having issues with that, let me know. Okay, all right, there's our first lesson on using SOHCAHTOA to help solve right triangles. Tomorrow, we'll talk about this in class. There'll be an assignment for you to do, and then there'll be the video that you would watch about finding angles, okay? So, hope to see you on Teams.